You know those sections in your dashboard where your team manages users, permissions, roles, units, whatever your business runs on, and the users of the dashboard need to create new records or edit existing ones. And now you have to decide, where does that actually happen? There is inline editing, where you edit stuff right there in the table, where everything is fast and easy, and it works fine for simple things like flipping a toggle or editing a single field. Then there is the split screen, where you see the list on one side and the form on the other side. This is the way opposite of the first choice. This is for the complex stuff, where someone needs to see everything at once. But for day-to-day operations, you are usually choosing between two paths. Either you send someone to a whole new page, like an edit page, create page, whatever, or you keep them on the same page of the list by opening the form in a pop-up or a drawer. Now this might sound like a simple UI detail, something you just check off and move on, but it's not. It's important. It affects how fast your team can work, how much context they lose when they switch between records, how many clicks it takes to get things done. It even affects how easy it is to add new features down the road, or how much technical depth you pile up. So, when you are working on your dashboard, either it's for your SaaS, your internal tool, or for your clients, this isn't just a design choice, it's a product decision. And that's what I want to talk about in this video. First is, how do you actually choose? It's not about choosing what looks nice. It's about how you build the thing and how your people will use it every day. So here is how I break it down. Go with a dedicated page when the information is sensitive, like password, credit card credentials, or personal data, things that makes people nervous. You don't want someone squinting at a half screen, being afraid if they got themselves doxxed. A full page feels serious. It gives room to focus, and honestly, if they want to grab information from another app like a password manager or an email, they won't be afraid that their progress will be lost. The information needs explanation. Some fields aren't obvious. They need explaining, like a code that you need to generate or a setting that has consequences. When you need instructions, you need a full page, where you can add context, examples, and even warnings. A simple example about that is if you need the user of the dashboard to name the products in a certain way, like to follow some pattern. So you add the context of the pattern and you give examples of the naming. The form is too long. I'm talking about multiple sections, scrolling, the thing that takes a few minutes to fill out. When a form has that much to it, a drawer can feel a little bit cramped. People lose their place and they rush. A full page gives the form a room to breathe and helps the person stay in the right headspace in order for him to fill the form correctly. Now, when do you keep the users on the same page? The form is short. Few fields, name, type, a couple of drop downs, things that can be filled in under 30 seconds. In this case, sending someone to another page feels like overkill. The information is straightforward. No instructions needed, no sensitive data, just usual fields that the users of the dashboards deals with it every day. When it's familiar, it's fast, and fast matters. The users of the dashboard need to reference the list while they are filling the form. If someone is creating an order and needs to check the details of the customer, or editing a unit and you need to see what's already there, keeping the list visible here, it's a game changer. A drawer in this case will let them look back and forth at the list. They are power users. The people who use the dashboard every day, all day, they don't need context, they need speed. A drawer in this case will let them fly through the records without losing their place. One click, edit, save, next. No reloads, no waiting. So that's the framework. Sensitive info, full page. Needs explaining, full page. Long and complex, full page. Short and simple, same page. Need to reference the list, same page. Power users flying through records, same page. It's not about what is easier to build. It's about the person using it. Now, let's talk about a real project. I was tasked to make the front end of a dashboard for the real estate department. Properties, units, tenants, all the usual stuff. And my job was not just make it work. I had to make it easy to use, maintainable, and this is the most thing that they cared about, still works in 5 to 10 years from now. So, before I wrote any line of code, I looked at the information they were saving and dealing with, and here is what I found. The forms were short. The biggest one, maybe 15 fields, and most of them half of that. The information was straightforward. Names, dates, a couple of radio buttons, nothing too sensitive, nothing needed a manual, and just simple data entered by people who do this every day. For the people, they were power users. They used this dashboard every day. They didn't need context, they needed speed. They needed to jump from one record to another without losing momentum. So the choice was clear. A dedicated page will break their flow. Reload, tabbing back and forth, waiting for things to render. That's not how you treat people who spend 8 hours on your software. A drawer kept them in place, let them reference the list whenever they need to, let them fly through records. Open, save, next, open, save, next. No waiting, no friction. So that's why I chose a drawer, not because it's trendy, but because it fits how this team works. Once I knew that the drawer is the best fit, I stopped thinking about one form and I started thinking in systems. Because this dashboard had multiple sections: units, properties, tasks, tenants, vendors, leases, all kinds of sections. I didn't want to create a form for each one of these sections. I wanted to create one form drawer that can handle them all. Just change the configuration and change where the data should be sent and go. First question was, what input types do I need? I looked across every section. Text, number, date, email, radio, checkbox, and combo box for making things easy to choose, let's say, a city by name, but actually sending the ID. That was the core set. Then I looked to how these sections relate to each other. Units belongs to properties. Properties belongs to cities. And many of the sections, like leases and tasks, need to enter the unit that they are assigned to. So the user have to pick a unit through a drop down, like a list of God knows how much units, and some of these units have the same name. It's a punishment. Here I needed to talk to the backend team. I did not want them to send me all the units together. I needed them in a hierarchy: cities, properties, and units. And they said, okay. So now I have two input types: combo box city property and combo box city property unit. So this is how they work. You have three combo boxes. First is for the city. You choose a city from it, and the combo box of the property now only shows you the properties that are belong to this city. Okay, and you have, if you are on the combo box city property unit, you have a third combo box that is unit that now only shows you the units that belongs to this property. Now, what are these input types as components, which means as files, are responsible for? Not much, and that's the point. They receive simple instructions: what label to show, if they should be hidden, if they should display an error message. They get the value from a form and they send back changes. That's it. They don't store anything, they don't know about the backend, they don't care in what section they are in. And they are the bottom of the stack. And here is why this matters so much. If tomorrow the design team needed to change the look of the input types across all the forms, they only need to change these files. Just update in one place and it will be applied across all forms. This is the kind of maintainable that I was talking about. Now, above the input components, the one that actually renders the text and the dropdowns, there is a file that is called the field mapper. The name tells you everything you need to know. It maps the fields to the components. Here is how it works. There is a configuration file that has all the fields that we need for a form. It is passed down to the form drawer, which is the component that holds everything together. It loops through the configuration file, and for each field, it renders a field mapper. Now, the field mapper, look at this single field and see what is it. Is it a text? Is it a number? Is it a drop-down, a combo box, city property hierarchy? Then it renders the matching component for that field. It hands it the value that it needs and tell it where to send the changes. This is where the magic of the automatic rendering happens. You don't wire the fields manually. You only list the fields in a configuration and the field mapper handles the rest. And here there is a great performance trick. Each field mapper watches its own field. So if someone types in a text input, only that text input re-renders. All the other inputs stay the same. No extra work, and that's great for performance. And the mapper also does a prep work. It gathers all the information that the input field needs, like the label, if there is any error messages, if it should be hidden, and passes them along in a consistent format. So if you need to add a new input type down the road, you will only need to create a new component for it and then add it to the switch statement in the field mapper. And now all the forms can use this new component. Super maintainable. Now for the component that holds everything together, the form drawer. This is the drawer itself, the panel that slides open, but it does way more than just slide. First, it responds to open and close. It does not decide when to open or close. This comes from elsewhere. But when it gets the open signal, it slides open, and when it gets the close signal, it slides shut. And it calls back to let the rest of the form system knows what happened. Did someone cancel? Did someone click outside of the drawer? Or did it submit successfully? Second, it owns the form. It creates the form container, set up React hook form, and wires everything together. This is where the fields actually become a working form. Third, it builds the validation. From the configuration file, it generates a complete Zod schema. Required fields become required, optional fields stay optional. Everything is validated without you writing any validation rule with your hand. Fourth, it sets up the initial data. Create mode, empty form. Edit mode, pre-filled form with records data. And if someone closed the drawer halfway through and came back, it can restore their draft and no data will be lost. Fifth, it passes down everything to the field mapper. Like the fields and the error messages, everything will be passed to the field mapper in order for it to render the right components with the right information. Sixth, it handles submission. If someone clicked create or update, it runs the validation, packages up the data, it sends it to the onSubmit function. It does not submit on its own because the submission functionality will change from one section to another. And if the server throws an error back, it will get this error, merge it with the client-side errors, and send it back to the correct component in order for the error message to be displayed right next to the field. Now this may sound like a lot for one file to do, and in some projects it will be. If we had complex validations, dozens of fields, or maybe weird business rules, yeah, I would split things up, maybe move the schema to its own file, pulls the default values logic out. But for our case, we don't have any of that. The validation is simple. Is it required? Is it optional? Basic type checking, that's it. The default values are very straightforward, numbers, strings, empty arrays, nothing fancy. So for now, splitting this one file into 5 files wouldn't be smart architecture, it will be over-engineering. It will make the system harder to understand, not easier. The rule I follow is simple. Let the complexity tells you where to split. Right now, this file does only what it needs to do and nothing else. So, for now, according to what I read and understood about the data that they are working on, everything is fine. If they changed the way they deal with the information in the future, I will change the architecture that I have. So it all depends on your understanding of the data and how the team will be working on it. So going back to the form drawer, here is where it's scalable. It doesn't know anything about the section that it's in. It doesn't know anything about units, about properties, about tenants. It only knows fields, validations, values. That means that you can use this drawer in every section that you have. Only make a configuration file for that section. So no matter how many sections they want to add, either now or after 5 years, it's still the same way. Just make a configuration file for that section. No rebuilding, no duplication, just scale. Now for the hook, the use form drawer controller. If the form drawer is the component that slides open and renders fields, this hook is the mind behind it, the coordinator, the thing that makes sure that every drawer in every section behaves the exact same way. First, it controls the open and close state. It holds a single source of truth. Is the form open right now? In what mode are we in? Create or edit? Which record are we editing right now? And it gives you simple functions to change this state. Open create to start fresh, open edit to load an existing record, handle dismiss when someone closes the drawer. Second, it handles the draft behavior. This one matters so much. If someone is working on a form and accidentally clicks outside the drawer, or they need to check something on the list and they want to come back to the form, in both cases, the drawer will close. Most systems will wipe the progress. Not this one. The controller marks it as a paused draft. When they reopen the form, everything is right there where they left. But if the user intentionally clicked on cancel, that clears the draft. Third, it manages the submit lifecycle. When someone clicks on create or update, here is what happens. The controller sets the loading state so the buttons will start spinning. It clears out any old errors and it calls the onSubmit function. And here is the important part. It does not know what this function does. It does not care if you are using fetch, Axios or inertia or smoke signals. All it knows that onSubmit returns a promise. If that promise succeeded, the controller closes the drawer. If it fails with errors, the controller keeps the drawer open for the user to fix what's wrong. Fourth, it holds server errors. When the backend says this field is wrong, the controller passes these errors to the form drawer and the form drawer to the field mapper and the field mapper to the correct input to show them where they belong. Fifth, it knows nothing about the form itself. No React hook forms, no Zod schema, no validation rules, no field configurations, nothing. It only knows here is how you open, here is how you close, here is how you submit, stuff like that. But the actual form logic, it's the drawer's job. And the actual API calls, that's the parent file's job. This separation is what makes it reusable. It works with any section, any form shape, any backend. You just give it the onSubmit function and it just works. Now, here is the payoff. After all this architecture, the inputs, the mapper, the drawer, the controller, what does each section need to do in order to use this system? 3 things, and they are all simple by design. First is a configuration file. This is where you define what the form looks like. Every field gets a name, a label, what type of input it is, and if it's required or not. So for a basic text field, that's it, 4 lines. So for something more complex like the city property combo box that we made, we only need a couple more labels to make the user understand what the combo boxes are for. But it's still only configurations. No logic, no conditional spaghetti code, just a clean list of fields that anyone can read and understand. Second, the API bridge. The page that shows the list, for example the units list, needs to tell the form system how to save the data. It's only one function that takes the data from the form, builds the payload that the backend expects it, and sends it. In this project, we were using inertia, which means wrapping everything in a promise. But if you are using fetch, Axios, GraphQL, or whatever, it doesn't matter. Success, close the drawer and refresh the list. Error, show the error messages next to the fields that failed. The page owns the API logic and the system owns everything else. Third, the initial data mapping. When you are editing an existing record, the form system needs to know how to turn the record's info into form values. Sometimes it's straightforward, name goes to name, date goes to date, that's it. But sometimes it's more complex. So this one function handles the mapping and gives the form system the values that it needs. So now for each section, you only need to do these 3 things. Make the configuration file, set the API bridge, and map the data correctly. This is all you need to know. Everything else is handled by the form system. Build once and use everywhere. Now, there is a question that I should answer. With AI today, why go through all of this? Why architect something so carefully when AI can spit up a working form in just seconds? It's a fair question. And basically, for a one form, AI wins. Quick, dirty, done. But here is what I've learned. AI amplifies what you already have. If your code base is a mess, AI will create more mess. If your architecture is solid, AI will help you build on top of that. So for today, you need 10 forms and AI can help you through that in a couple of hours. But let's talk about tomorrow. When a design need to change, are you going to change these 10 forms and hoping all look the same at the end? If there is complex logic is going to be added, are you going to hunt down all the 10 files? What about next year when the validations are now more complex and there is data formatting? Are you going to do this for each form, hoping it stay consistent? What about new hires that they need to work on the same system? Are they going to read each form, understand its own quirks? Or are they going to open one file, understand the pattern, and work on that? This is the difference between building for today and building for 5 years from now. AI is incredible at execution, but it's terrible at consistency, at architecture, at holding things together for so long. The system that I was talking about does not fight AI, it enables it. If you need a new section, just describe the fields that you want, give it to the AI and it will give you the configuration file. Done. The system will handle the rest. Need to change how an input looks across all forms? Change one file. AI or not AI, everything updates. So yeah, AI changes the game, but it does not change the fundamentals. Good architecture still matters, maybe now more than ever. Because when your business grows, new teams, new features, new sections, you want a foundation that scales with you, not one that crumbles under its own weight. This is how we make software that still makes sense a decade from now.